you have two people, team A, sitting on each side of the molecule, because for DNA replication, it occurs at the same time. And I will go into and explain what that means. And the other, from team B, the nucleotides, they are free-floating nucleotides, and this all takes place in the nucleus during the S phase of interphase. Okay, you need to do some labeling. In the kit, you also have some cards that says 5' and 3'. It will have written on old, and you'll also have some that will be used for new, and we'll use those in just a moment. So the first thing you need to do, and these are your directions, we know that we always build, that's the key word, build 5 to 3'. And we learned also that it occurs anti-parallel, which means in opposite directions. We're also going to use the term leading strand and lagging strand. And again, we're always referring to what is being built. So this is the parent or the original strand that we are building the new strand from. So the first thing we need to do is we need to determine which side is the leading strand and which side is the lagging strand. Since we know on the old strand it's going 5 to 3', anti-parallel, it means that the new strand will go in opposite directions, which means 5 to 3'. So, and for this particular activity, I am going to move from bottom to top. And so when I open the DNA molecule, starting at the bottom, I will open the first two. Now there'll be, in some instances, where it will open up more, and in the directions, it actually shows it open up a lot more. So what it does is that what opens the strand is an enzyme, and it is called DNA helicase. ASC is referring to the enzyme. Hela would be the double helix. So it is a helicase, which is a helix breaker, which means it's going to cleave or break the hydrogen bonds as it moves across down the DNA molecule, whatever opens up. So as my enzyme is moving up, and again, we're just going to do two at a time. Okay, you have some tape in your kit. Tape the top of the molecule, and to keep it open, I tape the bottom, and then I'll just reposition the tape as I move up. So this is going to be my leading strand, because I'm moving from 5 to 3'. I am moving on this side toward the replication fork. So this is my leading strand. On the opposite side, which is anti-parallel, the parent strand, on this side I have 5' is my parent strand to 3'. So in this case, anti-parallel, my new strand I am building will now move from 3 to 5', which means that this is my replication fork, so I am moving when I build. This is my lagging strand. So it's like sewing, and I know that mentioned it before in the lecture video, that the leading strand is like sewing a straight stitch. It's continuous and it moves in one direction. The lagging strand is like a back stitch. I have to build in from the 5 to 3'. I can only add to the end of the 3'. So when it opens up, wherever the fork stops, I am going to start my build closest to the fork and move away from the fork. Okay? So let me go ahead and add those. Team B will hand me the correct nucleotide from the free-floating that are in the nucleus. So I have adenine will pair up with thymine. Notice how I have this set up so that I have my phosphate here, okay, which is going away, and then my exposed end of my other sugar. So at the same time, and you kind of have to work every other time just because as small as the molecule is. So I'm moving or adding my nucleotides toward the fork. So my next one is my cytosine. So I will need to get my guanine, and we may need some hydrogen bonds on each side. So I'm going to rotate this and attach the sugar phosphate. Some of these are kind of hard to push together. Okay, and so I'm going to continue the build, and my next one is thymine. Again, my sugar phosphate. And I would use the tape and pull it apart as I go. For the other side, the lagging strand, my new strand is now, remember my older parent strand is 5 to 3 prime, okay? And I move, and the old strand will go this direction, but my building strand, and that's what I'm focusing on, is moving away from the replication fork. So in this instance, I can only move away from the fork as it opens up. Here, I'm starting with the thymine, because this is the one that's exposed, again moving 5 to 3 prime on my build. And so let me add my adenine. And then what matches up with guanine would be cytosine. So you add the hydrogen bond and then link together your sugar. And then finally I'm going to go to my thymine. And notice the direction of my phosphate. Okay? Then the helicase is going to continue up and it's going to break the next bond. And I'm just going to go ahead and break 3 just to speed up the process. You can do 2 or 3. The direction says 2. Okay, so I'm going to come back over to my leading strand. And so again, 5 to 3 prime, I move working toward the fork. So then I'm going to add to this next one. So adenine and thymine. And again, if you just alternate back and forth, and then guanine and cytosine. And then guanine and cytosine again. Then I'm going to come over to my lagging strand, and again I'm moving away from the last bond that's been opened by the DNA helicase, the closest to the fork that's been exposed, and now I'm going to start with the cytosine and move toward what I've already built, or the fragment that I built. So cytosine is going to match up with guanine, and then I need another guanine. And then I need an adenine. And then these 2 fragments match up.
These fragments are called Okazaki fragments, named after the scientist who discovered the process of leading and lagging strands.
And then the last bond will open up, and then I add the complementary. So we'll do the leading strand first, and that will match up with adenine. And the adenine will match up with thymine. So now you notice that I've made 2 identical strands, and it's just how they are built. You still have the same end product. So you notice if you sit them side by side, okay, they are identical, a photocopy. And so that's what mitosis is making identical start with would be the DNA molecule, and then everything inside the cell is an exact copy